I'd like to illustrate the superposition principle by finding some solutions to a differential equation that we haven't solved yet. That is, y double prime plus y equals 0. Now this equation looks simple enough. It's a second order linear homogeneous differential equation. But in fact, we don't have the tools to systematically solve this equation yet. So let's just take a simple guess and find some solutions that way. Now the first thing you'll notice is that if you differentiate cosine twice, you get minus cosine. So in fact, cosine solves this equation. Plug in cosine, you get the second derivative is minus cosine, plus cosine is 0. Similarly, sine, if you differentiate it twice, you get minus sine. So sine also solves this equation. So we can quickly get two solutions to this equation. y1 is cosine x and y2 is sine x. Now, this equation is linear and homogeneous. So in fact, we can use the principle of superposition to generate a lot more solutions. In fact, any linear combination of these two solutions, cosine and sine, gives a new solution. So y of x equals c1 cosine x plus c2 sine x, where c1 and c2 are any constants. That's automatically a new solution of this equation. So for instance, I could take 3 times cosine x minus 9 times sine x, and I get a new solution. So we get lots of solutions starting with these two guesses and using the superposition principle. Now it's natural to ask, have we missed anything? So in other words, are there more solutions that we maybe haven't found just from this guess and the application of the superposition principle? So for instance, maybe I could find some function y3 of x, which is not a linear combination of cosine and sine, which is also a solution to this differential equation. See if you can find an example of such a function y3 of x. So for instance, I might think about it for a while and then realize that the function cosine of quantity x plus 1 solves this differential equation. Then I'll come back and say, well, is this a new solution? Is it a solution which is not a linear combination of cosine and sine? Now another interesting question to ask would be, are there enough solutions? Now what do I mean by enough solutions? Well, when we solve a differential equation like y double prime plus y equals 0, we're not usually looking to just find a general solution. We usually want to make a prediction by solving an initial value problem. So the question would be, are there enough solutions of this form, c1 cosine x plus c2 sine x, so that we can solve relevant initial value problems for this differential equation? Now you'll find actually that these two questions are very closely related.